Okay, guys, 10.2 is vectors in space. Section 6.3 and 6.4 was vectors. We did this finding the dot product and all that stuff. Exact same thing. We were doing the exact same thing. It's just a matter, instead of 2 letters, now we have 3. Okay, so let's talk about what a vector is. Remember the vector, you have to have what kind of notation? Parentheses or the funny little V things? Funny little V things. A vector is going to have the funny little V things. How do you know that something is a vector? Like what's the difference of that V? Remember, it's bolded, it's lowercase. So you're going to have the funny V things on the sides. That tells you that's a vector. It can also be written this way. Remember, with the I's and the J's and all that stuff? All that does is represent I is the first number, J is the second number, K is the third. It's like your X, Y, and Z. It's not X, Y, and Z in an ordered triple, but it's to be thought of that way. How do you find the component form? How do you find scalar multiplication? All that stuff is exactly the same as it was before. So we're going to talk, I'm going to skip through all of this. This is all stuff you've done before. I'm going to skip through it kind of quickly and then just go to some examples. But remember, guys, 2 vectors are equal if their corresponding components are equal. Equal means equal. It's the same. All right. How do you find magnitude? Remember, magnitude is the same as length. What does it look like? It's those double bars. That's not absolute value. And all you're doing is you're squaring each piece of the vector. So you're going to square each piece of the vector, add it together. Square, add, take the square root. And we'll talk about this a little more. How do you find the sum? What do? When you add and subtract. Right? Sum is adding and subtracting. So if you're adding 2 vectors, it's first with first, second with second, and third with third. Remember that? When you have scalar multiplication, all that means is like you have a number in front of your vector. So what do you do with that number? You distribute it. Good. And then to find the dot product. We talked about this before, but dot product is one singular value. It's one singular value. And how do we find that? It's first times first plus second times second plus third times third. Is that the mathematical way that the book says to do it? No. But that's what I want you guys to remember. First was first, second was second, third with third. How do you find the component form? How do you spell component? Component. I'm close. Go with it. Component form is terminal. What does that mean? End minus initial, which means what? Yeah. So you're going to get an ordered triple. And again, I'm going to go through examples of all this stuff, but you guys have seen this in chapter 6. You take the ending, subtract the initial. First with first, second with second, third with third. So let's just go through some examples. Let's go through some examples. Obviously, I took this from a book because we didn't have the PDF of it, so that's why it looks a little janky. But it says find the component form and magnitude of vector v, having the initial point and the terminal point. So how do you find component form? It's terminal minus initial, correct? So what's the terminal point? 3, 6, 4, minus, what's your initial point? 3, 4, 2? Everybody with me? Yes? Okay, so we're going to find vector v. So vector v, I'm going to have a little sideways arrow thing, however you want to say it. But guys, remember, it's first with first. So what's 3 minus 3? 0, comma, second with second. So 6 minus 4. 2, good. And then third with third. 4 minus 2 is 2. There, you guys just found vector v. Mm-hmm.
Why don't we add any of the negatives in front of the both images? Since 6 is a larger than 4. Oh, wait.
Because it's terminal minus initial. It's just, you're fine. Now we're going to find the magnitude. That's what this looks like, the magnitude. Whoop, this is V, right? How do you find the magnitude? Well, you just square each piece of your vector and add it together. So my first piece of my vector is 0 squared, plus my second piece is 2 squared, plus my third piece is 2 squared. Everybody with me? Now we simplify, God bless you. What is 0 squared? 0 plus 2 squared is 4, plus 2 squared is 4. So this becomes the square root of 8. Do we leave it like that? No. This is 4 times 2, so when you take out the perfect square, this becomes 2 square roots of 2. That's your magnitude. If you guys don't remember this, hopefully this isn't too terrible then, but this is section 6.3 and 6.4. Just instead of 2 numbers, it's 3. So dot product. Remember, dot product is one singular value. You're not going to have a vector. It's just going to be one number. So how do you find the dot product? Well, I have u and v, whatever. It's first times first, plus second times second, plus third times third. So it's 4 times negative 1, plus 0 times 3, plus 1 times 2. First with first, second with second, third with third. So what's 4 times negative 1? Negative 4, plus what's 0 times 3? 0 plus 2. What's negative 4 plus 0 plus 2? Negative 2. There's your dot product. Anybody have any questions? Okay, now we're moving on. The angle between two vectors. What is the only difference here? Or is there a difference from the last one? You guys remember this? Find the angle between the two. It's the magnitude. The dot product on the top. And then the magnitudes on the bottom. Is there a difference in the formula? Here, let me tell you. No. All right. It says, here's the formula. It's just cosine of theta equals the dot product at the top and then the magnitudes at the bottom. So this is just a little bit longer because there's more numbers. So it's cosine theta. Find the dot product first. I'm going to write it all out. So it's 1 times 3 plus 0 times 1 plus 2 times 0. You guys agree with that? Okay, so then we're going to find the magnitudes of each and multiply them. So it's 1 squared plus 0 squared plus 2 squared. And then for vector v, it's 3 squared plus 1 squared plus 0 squared. And you're going to multiply those two together. That's it. You just have the dot product on the top and the magnitudes on the bottom. So it's cosine theta equals, let's simplify. What's 1 times 3? What's 1 times 3? 3. Plus, what's 0 times 1? 0. Plus 2 times 0 is, so what do we have on top? 3. Okay, now let's go on the bottom. Two different square roots. 1 squared is 1, plus 0 squared is 0, plus 2 squared is 4. So it's a square root of what? 5 times 3 squared is 9, plus 1 squared is 1, plus 0 squared is 0. So here, yeah? Now, you could put this in your calculator right now, or if you wanted to simplify a little more, you could say cosine theta equals 3 over the square root of what? 50? A house times a house, just a bigger house. If you want to break down 50 into 5 root 2, whatever, it doesn't matter. But you would just put this in your calculator. So grab a calculator if you have one. Anybody have one handy? Carla's got it. What is 3 divided by the square root of 50? You got a little decimal, right? What do you get? Okay, so 0.42 what? 4246. Okay, is that the actual angle measure? Is your angle measure 0.4? No, how do you find the actual angle measure? You got to do the inverse. So hit second cosine, so that little negative 1 comes up, and then put in 0.4246. And what do you guys get? Just hit second, yeah, there you go. 64.9. So 64.9 degrees. That's the angle in between. And again, guys, the more we practice this, and again, you've seen this already, it should become fairly simple for you to just kind of go through. Just the mechanics behind it. All right, now I changed these notes a little bit. I just wanted you guys to see some stuff. All right, let's talk about orthogonal. What's the other word? This is the physics name for what? What does orthogonal mean?
That it's a right angle.
Yes, 90 degrees, right angle. So if they ask you, are these two vectors orthogonal, or prove that they are, or something like that, what do we have to use to find that? Does anybody remember? Your dot product has to be what number?
0.
Perfect. Look at you. Dot product has to be 0. So how would you show me that? Well, you would say first times first. So 4 times -1 plus second times second. 8 times -2 plus third times third. 2 times -1/2. What is 4 times -1? -4. What is 8 times -2? -16. And then what is 2 times -1/2? -1. What's -4 minus 16 minus 1? It's -21. In order for something to be orthogonal, the dot product has to be what? 0. So your answer to this question would be, nah, not orthogonal. None. Isn't. Nope. Whatever. But this is not really what I'm looking for. 10-point question, that's worth 2 points. I need to see you guys prove why it is or why it isn't. Does that make sense? All right, then we're going to do a couple of these down here. I just made these up, and then this last one, and we're done. Okay, this next set of examples, U and V. This is a vector. I know it's a vector because it's written with the letters. I don't think it's a good idea to leave it with the letters. Go ahead and write it in vector form with just the numbers. What would U be? What number's in front of I? -1, good. What number is in front of J? +6. And what number is in front of K? -7. Perfect. Look at vector V. First of all, I notice that I have a fraction. That means if I have a fraction, my answer should stay in a fraction. So what is in front of I? 1/2, okay. What is in front of J?
0.
There isn't one. Good, so it's 0. Perfect. And then what's in front of K? 12. And now we just do the norm. Do the usual. What is number 1 here asking you to do? 2 things. We're going to distribute -3, right? Distribute the -6 and then combine them. So I would go ahead and write -3 and then put your vector V. Look at the order. It's not U and then V. It's V and then U. So it's what? 1/2. What did we say it was? 1/2, 0, 12? And then I have -6 into U, which is -1, 6, and -7. Now, I told you guys before, there's a bunch of different ways to do this. I personally am going to distribute -3. I'm going to distribute -6. And then I'm going to add them together. Some of you like to keep that negative there, distribute the 6, and then change all the signs. I don't like to do that. So I'm going to say first, -3 into 1/2 is going to give me -3/2, right? What's -3 times 0? 0. And then what's -3 times 12? -36, okay. Now I'm going to say plus, and I'm going to distribute a -6. If you want to leave the negative there and distribute it later, you can. I just don't like to do that. What's -6 times -1? 6. What's -6 times +6? -36. And then what's -6 and a -7? +42. And now we add these two together. Okay, so first with first, we're going to say -3/2 plus 6. This is the hardest math you're going to have to do, guys. -3/2 plus 6/1. Well, what's the denominator here? 2. This becomes a 12. So what's -3 plus 12?
9.
So -9 or +9/2. Perfect. Then I have 0 plus -36. -36. And what's a -36 and a +42?
6.
Perfect. Now, if I asked you to find the magnitude, what would you do to all three of those numbers? Square them and add them, and then take the square root. All right, look at number 2. Don't get confused with parentheses and all this stuff. Look at this problem. It says 1/3 times negative u plus 5 times v. So what should you do first? Remember when you have parentheses, how do you work? Inside out. Good. So I'm going to leave my 1/3 hanging out over here. So I have a negative, what's my u vector? -1, 6, -7, plus 5 times v, which is 1/2, 0, and 12. So think about what we need to do first, guys. Let's work inside out. Leave 1/3 hanging out here. What do I do with that negative that's out in front? I have to distribute it into this vector. So this actually becomes 1, 6, 1, -6, and +7, correct? Plus, what do I do with this 5? Distribute it. So this vector is 5/2, 0, and then what's 5 times 12? 60? Okay, so now what do? Do I distribute that 1/3 in yet? Or do I add the two vectors together? You add them together. Always work inside out. Good. So this is going to become first times first. Well, 5 halves or 1 times 5 halves is 5/2. What's negatives? I'm adding. Yeah. Sorry, I should be adding. Trying to go too fast. We're adding them together, right? So 5 halves and 1. Well, 1 whole is how many 2's? 2/2, right? So what's 2/2 plus 5/2? 7/2, good. -6 plus 0. -6, and then 7 plus 60. 67. Perfect. And then what do I do with the 1/3? We now distribute. So boom, boom, boom. What happens when I multiply 1/3 and 7/2? 7/6, perfect. What is the same thing as multiplying by 1/3? Same as what? Dividing by 3? Okay, so what's -6 divided by 3, or -6 times 1/3? -2. All right, and then 67/3. Does that simplify it all? No, add 6 and 7, what do you get? 13? Is 3 going to 13? No, so there you go. Everybody good? All right, last one, magnitude. We're going to take u vector and find the magnitude. So I'm going to square each piece of my vector and add it together. So I have -1 squared plus 6 squared plus -7 squared, and then we take the square root. So simplify. What's -1 squared? 1 plus 6 squared is 36 plus 7 squared is 49. Now we're going to add that together. What's 49 plus 1 plus 36? 86. Okay, now you're like, uh-oh, I don't know if that breaks down or not. Let's do our little upside down division here. 2 goes in 86. How many times? 43. 2 goes into 8 4 times. 2 goes into 6 3 times. Yeah? All right, does 2 go into 43? 3, 4, 5, 6, 7. Are we good here? Just a square root of 86. Good, good, good. All right, this last one, I want you guys to think a little bit. I want you to think a little bit. It says the initial point of a vector is, okay. The initial point of vector v is P. What's the terminal point? Well, how do you find a vector? It's terminal minus the initial equals your vector, correct? You guys agree? Right, you have 2 points. You subtract terminal minus initial, and that gives you your vector. They didn't give us all of that information right here. What did they give us? they gave me the vector over here, which is 4, 2, and -1. And they gave me the initial point, correct, of 3, -1, and 6. I don't know the terminal point. We'll just call it A, B, and C. Thoughts? What are your all's thoughts? What can we do here?
Would you like subtract or in this case add 3, 4, and then add 1?
Okay, so you want to say, okay, so this is, could we do this? Can I do that? Mathematically, am I allowed to do that? Okay. So I still have this over here. I distributed that negative. So how would I solve for each one individually? You guys, 3 different people all said the correct same thing. We need to get the letters by themselves, right? So how would I get -3 to go to the other side? I'd add it. What would I add it to? What value?
4.
To the 4, okay. How would I get the 1 to go to the other side? Subtract it, okay, and to the 2. And then what would I do with the -6? I'm going to add it to what? To the -1. Okay, when I do that, I get A, B, C equals, what's 4 plus 3? 7. What's 2 minus 1? 1. And then what's -1 plus 6? 5. Okay, I got this point. How can I see if I did that mathematically correct? How could I check to see if that is, in fact, the correct answer? I can do terminal minus initial, can't I? I know it's terminal minus initial will give me my vector. So let's see what happens. I just found what I think to be the terminal point, right? 7, 1, 5, minus, what was the initial? So then they gave me 3, -1, 6. All right, so let's find the component form with these two and just see if we got it right. First minus first. What's 7 minus 3? What's 7 minus 3? 4, okay. What is 1 minus -1? 2. And then what is 5 minus 6? -1. Is that what they told me at the beginning that my vector was? So then yes, this is your terminal point. All you guys did there was set up your little equation of terminal minus initial equals the vector, and then you just solved. You solved for each piece individually, because each piece is individual of each other. That's probably one of the hardest problems that you're going to have, and that's not even really that hard. Just remember here, what do we need to do with this negative sign before we go to solve? You should distribute it first. It makes life a little easier, so you don't have to think oppositely. I don't know if oppositely is a word. That, ladies and gents, is a wrap. I will post the quiz review if you guys want to start looking at it. Now, again, guys, I made your 10-1 web assign, I made your 10-2 web assign, and the quiz review, which I'm not going to grade, all due on Thursday, which is the day of the quiz. Tomorrow we're going to go over some stuff. Don't wait until Wednesday night to be like, oh, I have 17 homework assignments. Get them done now. You guys have like 15 or so minutes right now. Go ahead and get started on either 10-1 or 10-2. Ask me questions, whatever. And then you can start on the quiz review.